Okay, number 2, radium decays exponentially, so we know we're going to use exponential decay and growth formula. It has a half-life of approximately 1600 years. Find a formula for the amount Y remaining from 50 milligrams of pure radium after T years. So we're trying to find a formula for this. And although it doesn't look like we have two ordered pairs like we did in problem 1, we actually do. We know that our initial amount is 50, so 0, 50. When T is 0, our amount is 50. And that says it has a half-life of 1600 years. So that means after 1600 years, there's going to be half of this left, so 1625. So we can start off by putting our initial value in for y sub 0. We get y equals 50 times e to the kt. Use our other ordered pair to substitute in and solve for k. So the 25 is our y value, 1600 is our time. We get 25 equals 50 times e to the 1600k. So we're going to divide both sides by 50. We get e to the 1600k equals 1/2. And to solve for k, we're going to need to take the natural log of both sides. Since these are inverses, they cancel out. We get 1600k equals natural log of 1/2. And then to find k, we're going to divide both sides by 1600. And remember, this k value is something that we need in probably the next part. So I'm going to store that for x. We get natural log of 1/2 divided by 1600. And I'm going to go ahead and store that for x. So now that's going to take place of the old x that I had stored from the last problem. So we've got this negative 4.333, so on, e to the negative fourth. That's just scientific notation, like times 10 to the negative fourth. So we have to move that decimal over 4 places. So we get negative 0.000433. But now we have that stored in our calculator, and we can use that for the next problems. Part A just asks us to go ahead and find the equation. So we've got it now. Y equals 50 times e to the negative 0.000433 t. Part B asks us, when will the amount remaining be 20 milligrams? So we know it's going to be longer than 1600 years, but we want to figure out at what time is this our amount. So that's actually going to go in for our y value. So we want to know when is 20 equal to 50 times e to the negative 0.000433 t. We're solving for t. So if we divide both sides by 50, we get e to the negative 0.000433 t equals 2 divided by 50 is just 0.4. So we take the natural log of both sides, and we get negative 0.000433 t equals natural log of 0.4. So to figure out the time, we just have to divide both sides by our k value. So we're going to do natural log of 0.4 divided by x, just so we stored that in there. So we get 2,115 years. We'll round to the nearest year.